Consider Taylor's theorem for e to the x. We know that the derivative of e to the x is equal to e to the x. Therefore, the Taylor series centered about 0 for e to the x is x to the n divided by n factorial. If we expand the series for e to the x, we see that it is equal to 1 plus x squared divided by 2 factorial, and so on. If we substitute ix in place of x, we see that e to the ix is equal to 1 plus ix plus negative x squared over 2 factorial plus negative ix cubed over 3 factorial plus x to the 4th over 4 factorial, and so on. You should take a moment to observe the circular nature of powers of I. If we repeat this exercise for sine x, we see that the derivatives of sine x are as follows. Cosine x, negative sine x, negative cosine x, and once again to sine x. A similar exercise can be repeated for cosine x. With this, we can develop the Taylor series for sine x and cosine x. Sine of x is equal to the sum from 0 to infinity of negative 1 to the n divided by 2n plus 1 factorial multiplied by x to the 2n plus 1. Cosine x is similar. It's equal to the sum from 0 to infinity of negative 1 to the n divided by 2n factorial multiplied by x to the 2n. Returning to e to the ix, if we rearrange the terms by grouping odd and even terms together, we can see through a simple analysis that e to the ix is equal to cosine x plus I sine x. You'll notice that the terms for sine are odd and for cosine are even. You should take a minute to expand the Taylor series for cosine x and sine x yourself.